And I'd like to thank all of you for attending today's webinar with Jonard Tools. Today's host is Jose Almanzar, and he is their marketing communications specialist. If anyone has any questions, please. Jose will be able to answer them at the end of today's presentation. Jose, thank you so much for being with us today. We greatly appreciate it. Looking forward to your presentation. And I'm finished, so you go ahead and take it on over.
Awesome. First of all, thank you so much, Julie, for giving me this opportunity to present. And thank you for everyone else also who decided to join me today. So the topic that we're going to discuss is fiber optics and the basics of fusion splicing. So first, I think it's important for me to go over a little bit of the basic features of fiber optic cables. In particular, I want to go over the structure of a cable and also go over how the light travels through the cable to ensure that we have connectivity throughout the world. So what does a fiber optic cable look like? As most of you probably know, optical fibers are made from glass, and it consists of a core, a cladding, and a bunch of protective layer. So obviously, glass is very fragile, so this protective layer is absolutely critical to ensure that it remains safe from external factors such as bad weather, contaminants, even animals and things of that nature. Now, typically, when you prepare a fiber optic cable, and we're going to go over this a little bit more later, you would use a wire stripper to remove the outer jacket, the secondary buffer, and the primary buffer. And you would use a Kevlar cutter to remove the strength member, which in this case is just Kevlar. Cool, so how does it work, right? How does light travel through a cable to ensure that we have connectivity? So for us to understand this, it's important to understand a term called refractive index. Now, refractive index is basically a measure of how much light bends when it enters a material. So when light travels from something that has a high refractive index to something that has a low refractive index, what typically happens is that the light bends. And so in terms of a fiber optic cable, the core is composed of a higher refractive index than the cladding. And so when the light is emitted towards the cladding, it essentially allows for this mechanism called total internal reflection, which allows the light to essentially zigzag throughout the cable. And so that's how the light remains inside the core as it travels to its destination. Now, even taking into account this mechanism, the light is still susceptible to getting weaker at certain distances of the cable. And so to ensure that the light remains strong, what you would do is just add an amplifier to the cable. And what an amplifier does is it basically just strengthens the light signal so that it can continue to travel along towards its destination. So this is basically how the mechanism of light travel within a fiber optic cable works. Another thing that's important to know is the difference between a single mode and a multi-mode fiber. Honestly, the biggest difference is just the size of the core. For a single mode, it's a smaller core size, long distance transmission, and the technique of light being emitted is usually via laser optics. For multi-mode, the core size is much bigger, covers shorter distances, and uses LED optics as the mechanism. So what is fiber splicing, right? So fiber optic splicing refers to permanently or semi-permanently joining two optical fiber ends to create a continuous optical path for light transmission. So there are usually two main reasons for anyone to want to fusion splice or mechanical splice, and that is one, to fix a faulty cable, and two, to just simply extend a fiber run. So within splicing, there are two basic mechanisms. The first is mechanical splicing. Now, mechanical splicing involves aligning two fiber ends within a mechanical fixture or connector. The mechanism used in mechanical splicing is usually through index matching gel to minimize signal loss and back reflection. Now, a fusion splicer or fusion splicing uses a fusion splicer machine to fuse the fiber ends together using a controlled electrical arc. Now, this obviously is a lot more accurate just due to the high-tech system that you're using to fuse the fiber ends together. And the key benefits of fusion splicing are minimal signal loss, reduced back reflection, higher mechanical strength, long-term durability, and higher bandwidth fiber networks. Okay, so let's understand a little bit some of the splicing technologies and just go over some of the pros and cons of each. So when we talk about fusion splicers, there are three main kinds. There's a clad alignment fusion splicer, a core alignment fusion splicer, and a ribbon splicer. So we're going to go over a little bit of each, pros and cons, and some of the applications where you would use each fusion splicer. So a clad alignment fusion splicer is, as the term indicates, it aligns the fiber cable by the clad. Usually it's a much more cost-effective and straightforward approach to fusing fiber optic cables. And the system usually operates using a 4-motor system. This mechanism is actually the one that's most prone to higher splice loss compared to other methods. And this is because it's a lot less precise, right? We've already discussed the anatomy of a fiber optic cable, and the clad is a lot bigger, a lot larger than the core. And so if you're aligning it by the clad, obviously there's just a lot more room for error as opposed to if you're aligning it by the core. So the core alignment fusion splicer, again, as the term indicates, aligns the two cables by the core. Now, fusions or core alignment fusion splicers typically employ a combination of cameras, lenses, light sources, and 6 instead of 4 motors to precisely align fiber cores. It's a lot more sophisticated and higher cost technology, but it allows for enhanced splice quality with better control over core alignment on each fiber. So I'm going to go over just situations in which you would use each of these fusion splicers. So for clad alignment splicers, these are you would usually use them for general use and budget jobs. For instance, performing routine fiber maintenance on commercial buildings or fiber to the home, last mile system installations. For clad alignment splicers, like I previously mentioned, they're a lot more affordable. So if you're looking to deploy fiber quickly in an affordable manner, you would typically use a clad alignment splicer. Core alignment splicers are usually used for precision applications. Again, because you're aligning the cores, they allow for a lot more precision. And so things like data centers and just environments that require top-tier accuracy and performance are usually where you would see core alignment fusion splicers being used. And then the ribbon splicer actually allows you to fuse up to 12 fibers at once. So what this means is that in situations where you have high volume fiber deployments, you would typically see people using ribbon splicers because in these scenarios, time efficiency is very critical. And so the fact that you're able to fuse 12 fibers all at once allows you to work more efficiently. In terms of pricing, the clad is usually the most affordable, followed by the core, usually a little bit more expensive, and then the ribbon is typically the most expensive of the three. So what are some of the tools and equipment needed for you to successfully perform a fusion splice? So the very first thing you need to do is you need to have a wire stripper and Kevlar cutter. And again, this is essential for you to remove the outer coating of the fiber. You need a fiber cleaver, obviously, to cleave the fiber and ensure that it's clean cut. The fusion splicer, as we discussed, allows you to fuse the ends of the cable together. If you're fusing a cable into a connector, you would need splice-on connectors. And then this is very important, you need your cleaning supplies. This ensures that you're able to perform a smooth fusion splice, and you ensure that there is a minimal error as possible. And then after you're done splicing cables, you need your test equipment, right? Light source power meter, VFL, fiber microscope, and OTDR, depending on the magnitude of what you're working on. So these are some of the splicing procedures, a step-by-step guide on how to successfully perform a fusion splice. So the first thing you have to do, as I stated, is you need to prepare the fiber to be spliced, right? So basically you need to remove the outer coating. You need to make sure, and again, this is very important, to clean the bare fiber with lint-free wipes and alcohol to make sure you remove any debris and oils. You need to use a precision cleaver to create a flat, smooth fiber end face. This is a very important part of the process as well, because a lot of error is due to improper cleaving. After that, the fiber is prepared and ready to be spliced, and that's when you will align the fibers together and fuse them using an electrical arc. Now, keep in mind, once you fuse them together, the fiber glass is still exposed, and so you need to protect it. In order to protect it, you need to essentially apply a splice protection sleeve and a heat shrink and heat shrink it in an oven. Now, the heat shrinking in the oven just allows you to safeguard the splice from bending, moisture, and other potential damage. Finally, once that's done and you've successfully spliced and protected the fiber, you just want to test it with a OTDR, optical light source power meter, depending on whatever application you're working with, and just confirm that there's minimal loss and a strong connection. So I think it is actually better for me to just show you a quick video on how it's done, just for any visual learners that we have here. So I'm going to start this video. It's a quick one.
Operation. Open the fusion chamber and fiber holders if necessary. Seat the fiber in the V groove as close to the electrodes as possible without touching. Gently close the fiber holder and repeat with the second fiber. Close the fusion chamber cover. Splicing begins automatically. Slide the protective sleeve over the splice and place it in the heater. Press the heat button. The red light turns on with a beep, and once completed, it will turn off with a second beep. Remove the finished splice and place on a cooling tray and allow it to cool. Note, for connector splicing, swap to the included fiber holders. A separate video showing this entire.
Perfect. So once again, the fiber was already prepared, before he started the process of fusion splicing, but that's just a visual representation of what it looks like in real time. So in terms of the fusion splicing procedures, as we just saw, you've got to open the fusion chambers on both fiber holders, and this is essentially where you will place the fiber. You will place them as close to the electrodes as possible without making contact. Once you've done that, all you have to do is close the fiber holders, make sure the fiber is secure on both sides, close the fusion chamber carefully, and then the splice will initiate automatically. Now, once again, like I mentioned before, once you complete the splicing, you need to make sure that you slide in over the protective sleeve in order to safeguard the exposed glass. And once you position it in the built-in heater, it'll allow you to compress it and allow for the necessary protection for that fused cable. Now, there are essentially two different ways you can perform the fusion splicer. You can either splice two fiber ends together, or you splice one end into a connector. This is essentially the same process that you saw in the video. The only difference is, instead of you having a fiber cable on one end, you would have to unscrew that end and screw in the splice-on connector end so that you can splice the cable onto the connector. But the same process goes for this as well. You've got to make sure you align appropriately. You have to make sure you close the chamber. Slide in the protective sleeve once the fusion splice is completed, and then you go on to make sure that you test everything so that there's minimal signal loss. So this is really important. Once you're done with your fusion splice and you have your protective sleeve over it, you've got to make sure that you test the fiber, make sure everything's good, minimal signal loss. And you can do this either with a VFL, power meter light source, OTDR. This is really dependent on how accurate you want to be and what kind of situation you're in terms of the fiber deployment. But this is extremely important in making sure that the integrity of the fiber cable remains, and also to ensure that you properly spliced it together without any issues. Now, once again, you have to make sure that the cable is prepared accordingly before you perform the fusion splice, and you need to make sure that you have the cleaning supplies necessary to be able to test using the connectors and whatnot. So in terms of the importance of using a fiber microscope, it's absolutely essential because it allows you to inspect the end faces of the connectors. In terms of issues and problems with signal degradation and things of that nature, it's usually due to not having clean end faces of connectors. And so, you're essentially eliminating the possibility of having to do everything over, ensuring that everything is clean, inspected, and good to go. So these are some of the common issues and troubleshooting that we've heard from a lot of customers and just people in the field. Poor cleat quality is a big one. You've got to make sure that you use a precision cleaver and ensure that this step is done with care. Contaminated fibers is one of the big ones as well. You've got to make sure you have your cleaning supplies before you start the fusion splice. Improper fiber placement, also, making sure that the cables are aligned appropriately in order for the fusion splicer to do its magic. And then incorrect splicer settings. Now, every fusion splicer has its own settings, manuals. Just ensure that you familiarize yourself with those settings in order to make sure that you have the correct splicer settings when you are performing a fusion splice. Now, these are some of the costs of having a failed splice. Rework and labor costs, network downtime, which can be critical depending on the environment that you're in. Data centers, for instance, rely on network integrity and making sure that it's consistent and stable throughout time. Reduced customer satisfaction is an obvious one, and signal degradation. So what are some of the industry applications and trends in terms of fusion splicing? So in 2024, the US fiber broadband deployments reached a record 10.3 million homes, meaning there are currently 88.1 million homes with a fiber access. So obviously this is a huge amount of people that rely on steady and stable connections. Data center constructions have had a huge surge recently, especially for big tech companies like Microsoft, Meta, who are investing in AI data center construction sites. Obviously, they rely a lot on fast connectivity and reliable fiber. 5G infrastructure is steadily increasing throughout time. And then also in the workforce, there's just a big demand for certified technicians right now. So for these reasons, it's extremely important to have at least some familiarity with fiber, how it works, and to ensure that you know how to properly clean a cable, prepare the cable, splice it, and make sure that you test to make sure there are no issues. So some of the key takeaways, we went over the anatomy of a fiber cable and some of the mechanisms involved and how the light is transmitted throughout the cable. We went over some of the splicers and some of the tools necessary for preparing a fiber optic cable. We went over how important, I should say, preparation is in order to successfully splice. And lastly, how important it is to validate with proper testing, whether that be an OTDR, VFL, or whatever situation you're in. You have to make sure that there's minimal degradation, and you have to make sure that you have the necessary testing equipment to do so. So if anyone has any questions, I'll be more than happy to answer them.
Thank you so much, Jose, for that presentation. It was wonderful. And it looks like I do have some questions for you. Let's get started with the first one. Here we go. First question. Can you tell us, how does Jonard Tools handle arc calibration for temperature, pressure, or environmental changes in their fusion splicers?
Julie, you cut off a little bit. Can you just repeat the question real quick?
Of course. Here we go. I'll repeat right here. How does Jonard Tools handle arc calibration for temperature, pressure, or environmental changes in their fusion splicers?
Their fusion splicers. Okay. So just to make sure I get it right. So how does Jonard handle arc calibration for temperature, pressure, or environmental changes in their fusion splicers?
Yes.
Yes. Okay. So our software actually allows for, I believe it's monthly updates, depending on, for example, if any new cable comes out, or if there's any kind of like if Corning comes out with any new cable, or if there have been any changes, our system automatically updates to make sure that it's compatible with whatever cable you insert into the fusion splicer. I'm not sure is that the question that he asked?
Yes. Yes, you're absolutely right.
Okay. Yeah, and the splicers also have automatic arc calibration as well, in both our clad and our core units, which implies obviously that the splicer internally senses environmental parameters and adjusts these parameters to compensate for any changes in the environment.
Excellent. Thank you, Jose. Next question here for you. Are their fusion splicers waterproof, dustproof, or drop resistant? And if so, what ratings, IP, drop height, do they meet?
Okay, so I'm not too sure about whether or not they're drop resistant. I'm sure there are splicers that are drop resistant, but I can ensure that they're definitely waterproof. There are fusion splicers designed with ruggedness in mind, like water resistance and drop resistance and things of that nature. Now, they won't necessarily be fully waterproof in the sense of like submersion, but ours is built to withstand like field conditions, such as drip, spray, dust, and shock. So, we do take those into account when building out our fusion splicers. Yeah.
Excellent. Thank you so much. Next
Mhm.
question here. Do the splicers support firmware upgrades? And if yes, how are the upgrades distributed and installed?
Yes, they do support firmware upgrades. And usually you would see the option to upgrade just on the screen of your Fusion Splicer whenever that is necessary. So if there happens to be like a necessary update that you need to perform, the screen on the Fusion Splicer would indicate that and take you through the necessary steps that you would need to ensure that you update your firmware.
That's great. Fantastic. Thank you, Jose. Couple more questions left here still.
Yep.
Next one is, what is Jonard Tools' vision and roadmap for future fiber optic and splicing product development? If you could share that with us, that would be great.
Yeah. Sorry, you cut off one more. Can you just repeat that one last time?
Of course. What is Jonard Tools' vision and roadmap for future fiber optic and splicing product development? If there's anything you could share with us, that would be great.
Yeah, I guess in the general sense, we just want to make sure. So just so everyone knows, our Fusion Splicer is actually relatively new. We came out with it just a few months ago, and so right now we just want to ensure that we update our technology just based on the feedback of our customers. Right now we offer all three versions of the splicer, the clad, the core, and the ribbon. So at the moment, we're just focused on basically taking the feedback that we get from our customers and trying to, improve our technology according to that. We also know that one of the biggest problems for customers, not for us, but just in general, is that they don't get ample customer service when it comes to Fusion splicers, right? Like for instance, if there happens to be an issue with your Fusion splicer, or if there happens to be something that is confusing for the customer, or any questions they may have, I know a lot of them talk about how there aren't resources to seek help, but that's something that we actually thrive in. We make sure that we have people here ready to help anyone who may have any issues with the splicer, and we also offer a 3-year warranty as well for anyone who, if anything happened to anyone's Fusion splicer, then we're able to, do things like fix it, potentially replace it, so long as it meets, obviously certain criteria. But one thing that we pride ourselves in is, making sure we take feedback from customers and make necessary changes when applicable, and making sure that we attend to any of the customers' needs and questions.
Excellent. Thank you so much, Jose. Next question here for you. How does Jonard Tools manage quality control in manufacturing, given your many tools and kits?
Yes, so we do have a lot of tools, but for us, every time we drop a new product, we like to make sure that we focus fully on that product and making sure that product is successful. And we do so by just making sure that we implement a full team effort. Obviously, we do have a lot of tools that we have to, manage, and we have to update accordingly, depending on, what things change in the industry. But for us, I think what differentiates our product from everyone else's products is that we make sure that we dedicate ample time to each product. Like each product is its own entity for us, whether it be, basic tools such as wrenches, screwdrivers, to more high-end equipment like the Fusion splicers. We make sure that we oversee it fully from beginning to end, whether it be some of the detailed technology, and components of the tool, to the marketing, to the customer success relationship. We make sure that we give every single aspect of a product's development ample time. And for that, we have a lot of team members constantly working simultaneously on a product to ensure that we produce quality products that our customers can use in the field.
Excellent. Thank you so much, Jose. Last question here for you.
Yep.
And you touched on this a little bit. Can
Okay.
you give us an overview of your warranty policy or your made for life / lifetime guarantee in practice for fiber tool products?
Yes. So for most of our products, we have a made for life, a guarantee for life, lifetime warranty. So if there are any issues with your product, if it's faulty, if it's broken, you can just call us, and without any questions, we will replace your product and send you a new one. So obviously there are very small exceptions to this. For instance, like I mentioned, the fusion splicer, because it's such a high-end piece of equipment, we do offer a warranty, but it's a 3-year warranty. But for most of our hand tools, I would want to say about like 95%, maybe even 98% of our product, we do offer a lifetime warranty. So there's actually a video of one of our ambassadors in the skilled trades who happened to film a video of him breaking one of his tools on purpose, and then calling our customer support team and essentially asking them to replace it to see, how much, I guess, integrity we have in our lifetime warranty. But yeah, we have a full faith and confidence in our products, and that's why we offer that lifetime warranty, because we know that they are going to last you a lifetime, and if they don't, then we will gladly replace it and make sure that our customers are happy with their products. I would always encourage you, though, to always, when you're talking to a representative, to just ask about the specificities of the warranty, because like I said, there are just a couple of exceptions here and there, but for the most part, everything is made for life and guaranteed for life.
Excellent, Jose. Thank you so much for answering all of those questions for us today. And thank you to everyone for attending today's webinar. And if any one of you have any further questions, of course, please feel free to contact your sales rep, or you can email us at sales@microcomtech.com. And if you wish to view any of the products mentioned or shown today, please remember that we've recorded this presentation and it will be uploaded to our Microcom YouTube channel so we can all view it again. That's always great to be able to do that. Jose, until next time, I hope to do this with you again in the very near future, and we could, go over what's next for Jonard tools that you could share with us. Everybody, have a fantastic day.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.